Hello, I'll be going over lesson 3.3 first, linear inequalities in two variables. So what is a linear inequality in two variables? It is any inequality that can be written in one of the forms below, where x does not equal 0 and b does not equal 0. And you can see the four types right underneath the definition. So our first example, graph each linear inequality. Y is less than x plus 2. So we're going to first start off by graphing the boundary line, which is y equals x plus 2, and you would use a dashed line because the values on this line will not be included in the solution. And then you're going to choose any point, such as 0, 0, and plug it into the original equation and see if it is true or false. And if it does satisfy the inequality, you should shade the region that contains this point. And in this case, we use 0, 0, and it does fit. And then moving on to our second example, y is greater or equal to negative 2x plus 3. You're going to start by graphing the boundary line, y equals negative 2x plus 3. And this time you would use a solid line because the values on this line are included in the solution. And we're going to test 0, 0 again, and we can see that it turns out to be false. And since it does not satisfy the inequality, we're going to shade the region that does not contain this point. And you can see the graph right underneath. Linear inequality in only one variable. X is greater than negative 2. So any ordered pair whose x coordinate is greater than negative 2 is a solution. So we're going to graph the original, which is y equals negative 2, and then we're going to shade the right side of the plane because the x value must be greater than negative 2. And then we're going to use a dashed line because the values on this line are not included in the solution. And then moving on to lesson 3.4, systems of linear inequalities. So what is a system of linear inequalities? It is a collection of linear inequalities in the same variables. The solution is any ordered pair that satisfies each of the inequalities in the system. To graph a system of linear inequalities, shade this part of the plane that is the intersection of all of the individual solution regions. So our first example, graph the system. X is greater or equal to 0, y is greater or equals to 0, y is greater than negative 2x plus 5, and y is less than or equal to negative or 3x plus 1. And the inequalities x is greater or equal to 0 and y is greater or equal to 0 tells you that the final solution region is in the first quadrant. And now you're going to graph the other two, and you're going to use a dashed line for the negative 2x plus 5, and you're going to use a solid line for the 3x plus 1. And then when you graph these two boundary lines, we're going to see where the solution is intersected, and we're going to shade in that region. And then moving on to our second example, graph each inequality in a coordinate plane. So a, negative 3 is less than or equal to x is less than or equal to 2. And the solution is the set of all ordered pairs whose x coordinate is between negative 3 and 2 inclusive. So we're going to use two solid lines to represent x equals negative 3 and x equals 2. And then we're going to shade in the space in the middle or in between these two numbers. And this solution is a vertical strip. And moving on to b, negative 1 is less than y is less than 3. The solution is the set of all ordered pairs whose y coordinate is between negative 1 and 3. And you're going to use dashed lines because the values on this line are not included in the solution, and you're going to graph right in between negative 1 and 3. And this solution is a horizontal strip. Thank you.